find the value k so that the following equation is exact, then find the general solution. So this is given in the form of something like, let's say this is m dx plus n dy equals 0. And we know that when we have an equation in this form, and if partial of m with respect to x is equal to, partial of m with respect to y equals partial of n with respect to x, then if this is exact, then this is true. On the other hand, if this is true, then this will be exact. In this case, it's given exact. Okay, we have to make this exact. For we need to find the value of k. Okay, so let's find my here. With respect to y, derivative with respect to y, this is 0, is k. And let's find partial with respect to x. This is 4. And for this equation to be exact, these two numbers should be the same. Okay, this implies k must be equal to 4. So we can rewrite this equation in this way. Then the ODE becomes 5x plus 4y plus 4x minus 3y dy equals 0. Now this is an exact ODE. Now we want to solve this, and since this is an exact, we know that we can find a function uppercase capital F such that when we find the partial derivative of this capital F with respect to x, that gives first part, that's m 5x plus 4y, and when we find partial of uppercase F with respect to y, we get this 4x minus 3y. Let me call equation 1, equation 2, and we know that the solution of this ODE is just this function to be determined. The function equals constant. This will be the solution. Now we need to recover this function f from these two equations. Okay, we can integrate 1 with respect to x, or we can integrate 2 with respect to y. They are about the same. Generally we pick the simpler, but in this case either one. So integrate 1 with respect to x. So when we integrate with respect to x, we get just the function equals, okay, we are integrating with respect to x, and we are saying y is constant. So 5x, that is 5x is square over 2 plus 4y will be constant with respect to x, so 4y, and 1, that means 4yx, plus a constant, but that constant could be a function of y, so we write just hy. It can be a pure function, pure constant, a number, or it can be a function of y as well, because we are assuming y is a constant. These are partial derivatives. Equation 3. We are almost done, but we need to determine the value of this function h. Okay, look at 2. This is fy, partial derivative of f with respect to y. So let's find the partial derivative of this f with respect to y so that we can compare with 2. So from this f with respect to y, okay, this is a pure function of x, so with respect to y, just a constant, so 0. With respect to y, it's 1 4x plus, this is a pure function of y, so partial derivative with respect to y, which is same as regular derivative. Okay, now we compare 2 and 4. Left hand sides are same. Look at the right hand sides. 4x is here, they are same. That means h prime y should be equal to negative 3y. Okay, compare 2 and 4, we get h prime y equals negative 3y. Now integrate both sides with respect to y, we get h. So integrate, that's negative 3y square over 2 plus c, but we can take that just 0. Okay, we just need one h, not the most general h function. Okay, even if you write plus c, that will be absorbed later. Now with this h, we can go back in equation 3. This is h we just found here, and that's the function. And this function equals constant is a solution. Okay, plus c, then there's a constant, we can just always move to the right side. Okay, thus the solution is the function equals constant. So this is 5 halves x squared plus 4xy plus hy is negative 3 halves y squared. That's the function equals constant. See, final